In this video, we're going to look at how integration can be used to find the area between a curve and a straight line. So to start with, part A helps us doing the question actually. It tells you to find the coordinates of the points where the curve intersects the line. Now they intersect where the x values and the y values are the same. So what we can do is take the y equations for both of them and make them equal to each other. So let's do that. 10x minus x squared, we're going to make that equal to the equation of the straight line, 2x. You then want to move all the terms to one side. Here I'm going to move all the terms to the right hand side so that we get positive x squared, which is a lot easier to deal with. You also have to subtract 10x from both sides. 2x take away 10x is minus 8x. So I'm just going to straight away write minus 8x. And then all of that equals 0. Now to solve this, you first have to factorize it, and you can factor out x from these first two terms. So you'll have x lots of x minus 8 is all equal to 0, which you can then solve because the left hand side is only equal to 0 when x itself is equal to 0 or when x itself is equal to 8. That means that this x coordinate here is 0 and this x coordinate here is 8. Because it does ask for the overall coordinates, you can then substitute x equals 0 into either the equation of the curve or the equation of the straight line, because we know they both have the same y values at that point. Here it makes sense to choose the equation of the straight line because it's a lot easier to deal with. Y is equal to 2 times 0 when x is 0, so y is 0. And when x is 8, y is going to be 2 times 8, which is 16. Now that we've done part A of the question, let's move on to part B. I'm just going to increase the thickness of the pen actually. It says find the area of the shaded region. Now, if we draw a straight line down here, and if you find the area that the curve covers between 8 and 0, that gives you this area here. Or let's number this into sections. Section 1 is this shaded region, and section 2 is this triangle. If we integrate the curve to 10x minus x squared between the two x values, 8 and 0, the reason we choose the x values is because we're integrating with respect to x, dx. That gives you the area of 1 and 2, because it gives you the total area covered by the curve and the x-axis, which is all of this. After you found that, so let's do that actually. But if you guys did want to have a go yourselves, you would then find the area of this right angle triangle and subtract it from this total area that we're finding now. So when integrating this, you add 1 to the power, so it becomes 10x squared over 2. I'm just going to write that out in case some of you guys want to see it visually. So you add 1 to the power and you divide by 2. Now 10 divided by 2 is just equal to 5, so we can call this 5x squared. When integrating minus x squared, you add 1 to the power and then you divide by the new power. Now, because there is no plus c, there's limits involved, so we input the limits of 8 and 0. What this means is that you're first going to substitute the value of 8 into this whole function. So it's 5 lots of 8 cubed minus 8 squared. 5 lots of 8 squared minus 8 cubed all over 3. And then you take away the value that you get when you put the lower limit into this function. So 5 times 0 squared is just 0, and then 0 cubed is just 0, so it just ends up being 0. If you put everything that's in the first bracket into your calculator, I'm just going to very quickly do that. So we have 5 lots of 8 squared minus 8 cubed over 3. Now all equal 448 over 3. So let's just make a note of that. And like I mentioned before, that's the total area of section 1 and 2. Let's now find the area of section 2, but let's do this in a different color, otherwise it gets a little bit messy. So for the section of area 2, because it is a right angle triangle, we can just find the base of the triangle looking between the x coordinates of 0 and 8. We can then find the height of the triangle by looking at the y coordinates of 0 and 16. And then we can find the fact that it's the base multiplied by the height divided by 2. Now that will just be 4 times 16 because 8 over 2 is 4. Just a little trick to do those type of questions, and that'll get you 64. Now the shaded region only, like I mentioned, is the total area under the curve. Take away the area of this right angle triangle, which we've now found is 64. And that gives you the area of the shaded region that you're looking for in this question. So I'm just going to very quickly do that, and you get 256 over 3 as your final answer. If you did want to write out the decimal format, that's completely fine. But yeah, that's everything you do for this question. Be sure to leave a like if the video did help and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.